Hello everyone. So in this video, we shall see the space force systems. So space force systems, as earlier I told, the whatever the forces, normally basically they are classified into three types: collinear forces, coplanar forces, and space forces. So we shall see the third force system, that is space force systems. Earlier, whatever we have studied, whatever you have learned, so that is completely of collinear forces and coplanar forces. So this topic is somewhat difficult to understand, so that's why I have kept this on the last side, so at the end. So if you understood, it's good. So weightage of this topic in the exam is also very less. So if you understood, it's good. So if you're not, it's okay, no problem. So just I'm going to explain, and I'm going to try my best. First of all, we need to understand, so what is meaning of the space force systems, space forces. So space forces means if the forces acting on a body are in different planes, so means it is more than one plane, in different planes, then they are called space force system, or they are also called the non-coplanar force system or three-dimensional force system. So space force is called coplanar, non-coplanar also, and three-dimensional also. Means if the whatever the force acting, so if they are in three different planes, so then different planes. So if they are in single plane, they are called coplanar. Means co means single, coplanar means single plane. Okay, so space force means, so if they are acting in different planes, so if they are acting on the different planes, so then they are called the space force system. Okay, so this is about the uh, basic meaning of the space forces. So next is, before we are going to understand, so I am going to explain you certain terms, so which is used in the space forces. First is unit vector. So it is denoted by e bar. So e के ऊपर एक लाइन आता है तो उसको बोलते हैं बार, e bar. So what is meaning of this? It is a vector having magnitude equal to 1 unit. So its magnitude is 1 unit. It gives direction of line acting, direction of line along which force is acting. Means its magnitude is 1 unit. So you need to keep in mind is, so its magnitude is 1 unit. Okay, so afterwards, so it gives direction of force, and it is represented by e bar. So you may get questions in 1 mark question. So magnitude of unit vector is, so it is 1 unit, it's 1. Okay, so what is purpose of what it signifies? So it gives the direction of the force acting. So line of direction, line along which force is acting, so it will give the that direction. So next is position vector. So position vector, or it is also called the radius vector, so it is denoted by r bar. So first let us see this figure. So this is x-axis, this is y-axis, and this is z-axis. So these three are the three perpendicular axes. So in case of 3D, three-dimensional, so any point is represented by x, y, and z, 3 points. So in case of coplanars, so we are just going to represent by 2 points, x and y. So when there is z-axis, then z is also comes. So here they go. So here let I, j, and k be unit vectors along x, y, and z axis respectively. So I, j, and k are unit vectors. So what is meaning of unit vectors? So we have seen in the previous slide. So I, j, and k are the unit vectors along the x, y and z axis respectively. So next is let A and B and C be the coordinate points. So A, let us say for A it is x1, y1, z1, B is x2, y2, z2 and C is x3, y3, z3. Let us consider these points in the x, y and z coordinate. देखो what is meaning of position vector? The position vector, so position vector is always denoted with respect to the 2 points. So position vector of OA, so position vector of OA is and OA and BC, so it can be written as, देखो position vector of OA is denoted by r bar OA is equal to x1 minus this x value and minus this x value. Its x value is x1, its x value is 0, x1 minus 0 into I. So I clear. So this is I is the unit vector along the x axis. Next plus y1 minus 0. Similarly y, this y value minus this y value, y1 minus 0 into j plus z1 minus 0 into k. So x1 minus 0 means it is x1. So if we simplify it is x1 z1 x1 into I, y1 into j, z1 into k. So this is called the position vector of A with respect to O, that is OA. Similarly position vector of BC, position vector of BC is given by x3 minus x2 into I plus y3 minus y2 into j plus z3 minus z2 into k. So you may get the one more question on this. So how to, they may give the figure and they give the answers. So which is the position vector? So select the correct position vector. So in that case you need to understand so how to take the position vectors between 2 points. So next is unit vector along given line. So how to write the unit vector along the given line? So unit vector along the given line, the unit vector along the given line AB can be written as, so you just see here, so same figure, previous figure here, A and B. So you just see here, so force is acting from A to B. Okay, so unit vector along AB is given by R bar AB means it is a position vector and divided by magnitude of that position vector. So modulus means it is magnitude, we need to take its magnitude. So r bar AB is how it is a position vector, so same like earlier one, x2 minus x1 into I, y2 minus y1 into j plus z2 minus z1 into k. So in the previous slide I explained how to take the position vector divided by magnitude. So magnitude is given by x square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So this completely under the square root. So this will give the unit vector along the given line. So next is force vector. Force vector, so here you can see, so it is denoted by F bar. Let F be the force acting along the line AB as shown in the above figure. So that is this figure, so it is shown here. Force is F acting along the line AB. Force vector can be written as, F bar is equal to F into E bar AB. So here it is, F means it is indicates it is magnitude of force, and this E bar AB gives the unit vector along the line AB which gives direction. So direction of the force is given by this unit vector. So F gives the magnitude. So this is called the force vector. So we should know that, so force is a vector quantity, so it should be defined by magnitude and direction. So F will give the magnitude and E bar AB gives the direction. So next is direction of cosines. So you need to know the how to take the cosine of the angles. So just here it is considered, this is x-axis, this is x-axis, this is y-axis, and this is z-axis. So here, so let the F be force acting on the at the origin in the direction as shown in the figure. So it is a force F, so it is acting at the origin point, so it is as shown in the figure. So theta x, theta y, and theta z be the angle made by the force F with respect to x, y, and z axis respectively. So ये force का, so सभी axis के साथ angles, all axis with respect to all the axis. With respect to x axis it is theta x, with respect to y axis it is theta y, with respect to z axis it is theta z. Then so f x component is given by f cos theta x. So we know how to take the component of the forces along, it's like resultant force. So how to resolve force along three axis? So earlier we know that how to resolve along two axis, x and y axis. Now how to resolve along three axis? So x component is given by f cos theta x, y component is f cos theta y, and z component is f cos theta z. So in this way, so we can take the components along the three axis. Again, so lastly you need to know that cosines. So these things you need to understand. So earlier, so we can see force vector F bar can be written as, so it is, you can write this as a F bar is equal to Fx into I plus Fy into J plus Fz into K. So here I, J and K are unit vectors. So what is meaning of unit vectors? So earlier I explained. देखो Fx means what? So Fx means it is F cos theta x. So you can see here, so F cos theta x. Similarly Fy and Fz. So it is, we also know that F bar is equal to F into E bar. So if you compare these two, so these two equations, so we will get E bar is equal to cos theta x into I, cos theta y into j, cos theta z into k. So here, so its magnitude is given by is 1. That means it is cos square theta x plus cos square theta y plus cos square theta z is equal to 1. So this is called the cosine rule. So we already know this. Cos square theta x plus cos square theta y plus cos square theta z is equal to 1. And cos theta x is equal to, so you can just simply, if you take f on this side, so cos theta x is equal to fx by f, fx by f. Similarly cos theta y and cos theta z. So these are called the directional cosines, you can say. Okay, so this is all about the space force system. So just go through this. So you just try to understand, so you will get few questions on this. Okay, so if you have any doubts, so